Hi, everybody. This is Miss Lorette back again with another lesson for week 2. We're just going to continue with section 5.6. And again, this is still review. We were covering section 5.6 before we left school. So I'm going to try and do a review of what we had covered while we were in class. And then same thing as last time, I'll give you guys slides to practice. So here are my slides that I'll do. You'll get your own slideshow with different questions. And it'll be pretty much the same type of work that you'll do. So I've got one where you'll drag and drop the appropriate slope, just like last time. I've got ones where you'll type in your work. And just like last time, if you're confused on how to do those, consider rewatching this video and find the slide that looks like the one that you're currently working on. Okay, so section 5.6 is parallel and perpendicular lines. We're going to talk about perpendicular lines today. So as you might recall, parallel lines don't intersect. Perpendicular lines do intersect. They intersect at a 90-degree angle. So I created our table again, which we had last time, and I'm going to type in a few notes for the criteria that lines have to meet in order for them to intersect at a 90-degree angle. In other words, in order for them to be perpendicular. All right, so for slanted lines, again, the best forms, plural, are going to be slope-intercept form, y equals mx plus b, or point-slope form, y minus y1 equals m parentheses x minus x1. And just like last time, this is the best form. These are the best forms because you can see the slope. It's important that we know what the slope is. Reason being, in order for lines to be perpendicular, slopes are going to be two things. And I'm wondering if you remember what those two things are. You may actually want to grab your notes that you took from last time just to kind of review what we covered in class. Slopes are going to have to be opposite, meaning opposite signs. So if it was negative, it's now positive. If it was positive, it's negative. And they're also reciprocals. Okay, reciprocal means that if you looked at that number as if it's a fraction, you flip it upside down. So if the original number was 1 over 2, the reciprocal would be 2 over 1. Okay, so it's both things. And obviously, because we're saying both of these things, opposite and reciprocal are not the same. Opposite means you're flipping the sign. Reciprocal means you're flipping the number. So let's do an example real quick. Let's say I had y, I'm going to do it in point slope form. Let's say I had y minus 4 equals 3 parentheses x plus 7. Let's say that was my equation. Okay. This is going to be perpendicular to, and yes, there is a symbol for the word perpendicular. I don't know how to type it. I'm sure that I could go to insert, find the special character and insert it, but I'm not going to bother. I'm just going to use an abbreviation. That's going to be the quickest. So we don't really care about what the y-intercept is. It can pass through any intercept. It can pass through the same intercept. That being said, the equations that I'm going to give you are going to be very specific because, again, I'm going to give you a specific point. But I could theoretically use the same numbers for my y1 and my x1 so long as I make sure that this slope meets this criteria, that it's an opposite reciprocal. Well, let's think about what the opposite would be. That slope that I just highlighted, here's my slope, is positive. So I know I want my slope to be negative. Now let's think about what the reciprocal to 3 would be. If you're ever unsure what the reciprocal for an integer is, I highly suggest putting it over a 1 like this and then flipping it upside down. So let me just highlight that I just added that in. So if I flipped these two numbers around, instead of being 3 over 1, it'd be 1 over 3. So there's my perpendicular slope. Okay. So that's how we're going to approach slanted lines. All you're going to do is you're going to identify the original slope and make it an opposite reciprocal. And you have to do that right away before you do any type of equation conversions. which you'll see later. All right, let's talk about horizontal and vertical lines. I almost could have made this in the same column. I probably didn't even need to split them up like this. But horizontal lines, they're going to be in the form y equals a number. And horizontal, you know, if you think about a horizontal, it's a line that goes left to right. Let me see if I can draw one really neatly. Come on, I want the line. There we go. So here's a horizontal line. I'm going to try and get it as straight as I can. Put some arrows on the end. Now, if I want a line to intersect this at a 90-degree angle, the type of line that I'm going to need is a vertical line. So let me draw a vertical line. It's not selecting. Here we go. I need a vertical line. Let me see if I can move these. Move it down. There we go. So if y equals a number is a line like this where my mouse is hovering, I want a line like this where my mouse is now hovering. So this is going to be perpendicular to x equals a number. Okay, same thing over here. If I give you x equals a number to start with, then I'm giving you a line like this. That means it has to be perpendicular to a line like this, to y equals a number. So, for example, if I gave you y equals 3, this is going to be perpendicular to, I'm going to shift down here, x equals, and again, it could be the same number, it could be a different number. It'll be a specific number when we do examples because I'm going to give you an ordered pair, but let's say x equals -4. There are my two perpendicular lines there. Here's another example. If I started off and I gave you x equals 5, this is going to be perpendicular to y equals some other number. It could be the same one even, y equals 5. Because even if the number is the same, the type of line that it's being created here are different. Okay, so let's just do some slope practice. It says click and drag the matching slope to the equation that is perpendicular. All of these equations are the same as last time, but obviously our answers are not going to be the same. I have to now look at the slope in the equation and do two things to it. I got to make it an opposite reciprocal. Okay, and obviously if it's a horizontal or vertical, I can just refer to these, this part of my table to figure out what type of equation I need. Okay, so looking at the first one, it says y equals -1/2 x minus 3. My slope is right here. My slope is -1/2. Well, let me actually just show you how you can do the work here. And you don't have to do this. I'm just going to insert a little text box so you can see. My original slope is this, right? -1/2. I want to do two things to this slope. I want to make it positive because it's originally negative, so I want it to be the opposite. And I want to flip that number upside down. So what number does this look like to you? 2/1. Well, it's going to be +2. That's my answer for this one. My slope, which is going to be perpendicular to this slope, is going to be +2. Now let's take a look at number 2. X equals 7. All right, well, I know the type of equation that's going to be perpendicular to x equals a number. It'll be y equals a number. But you're not being asked to provide the equation that will be perpendicular. You're being asked to provide the slope that is perpendicular. So let's think about what the slope is for y equals a number. Okay, if it's a line like this, remember the video I showed you guys where the guy is skiing? On a surface like this, what does he say? His slope is 0 fun. So my slope for an equation like this, which will be perpendicular, is going to be 0. This equation has what type of slope? It's not 0, it's undefined. Okay, so 0 and undefined are perpendicular slopes to each other. All right, let's take a look at number 3. This one's in point slope form. Y plus 1 equals, and again, there's an understood 1 here. Remember, if there's an x on the other side, your slope isn't 0. If you have a y and an x, your slope isn't 0. You have some sort of slanted line. So my original slope is 1. That means I want to figure out what's the opposite reciprocal to that. Well, I could put the 1 over a 1 just to put it in fraction form. And I know I need to do two things to this. I need to do the opposite sign, so my slope has to be positive. And then I got to flip these two numbers around. Well, if I flip them around, it's going to look the same. So I can just simplify this. 1 divided by 1 is 1, and it's negative. So my perpendicular slope to this is going to be -1. See how I'm doing that? All right, now let's take a look at the last one. Y equals -9. So again, I can refer to this table here to figure out what equation would be perpendicular to that. X equals a number will be perpendicular. So now I just need to ask myself, what's the slope for a line like this? Well, a line like this is going to be up and down. Remember the video where the guy is skiing? What does he scream when he falls down the cliff? He screams undefined, and that's the slope that would be perpendicular to this. This had a slope of 0. Perpendicular slope would be undefined. And there's two slopes that I didn't use. So just be wary of that when you guys do your homework slide. Okay, so I'm going to jump to the homework so you can see. Yours looks like this. You only have 4 questions, but you've got more than 4 options. So a few of them will not be used. All right, moving on. So this is going to be similar to the problems we did last time, where I'm going to click in here and type out my work. Again, if you need to add more space, like if you're typing and you run out of space, you can click this text box and drag a text box over to the side and keep going. Okay, so we want to make sure that we're paying attention to the form we're being asked to write our answer in. Always start with what you know. In this case, I'm going to start with the formula we're being asked for. Point slope form is this: y minus y1 equals m parentheses x minus x1. So that's the form my equation has to be in, and that's actually the easiest form, because once you substitute everything you need, you're done. The next thing I need to figure out is, what slope do I want to use? You should always do that before you start substituting any numbers in your answer. I like to start by writing my original slope. My original slope is this. Remember, there's an understood 1 right here. I keep pressing that button. I want to highlight this, change color. Okay, here's my original slope, -1. I want to do 2 things to this slope. I want to change the sign from a negative to a positive. And if I make this a fraction, I want to flip it upside down. Well, it's still going to look like 1. 1 divided by 1 is just 1. So this is the slope that I need to use here. That's the slope that I want in my equation, a +1. So I'm going to do y minus, and now I just start substituting my values. I substitute the y value, where y1 goes, it's a -4, equals, instead of m, I'm going to substitute the slope that I want, which is 1. I'm going to open a set of parentheses and type x minus, and instead of x1, I'm going to type the x value, close parentheses. The only thing I can do from this point here is simplify the double negatives to give me a positive, and that is the only thing that you should simplify. You could drop the 1 if you wanted to and write it like this. You could even drop the parentheses and write it like this. So I'm actually going to just type a couple of options. You could type it like this. You could type it like this. Or you could type it like this. Oops, equals x minus 1. Any of these would be acceptable. You don't have to provide me all 3 if you get an answer like this. Just give me 1, but just know that all 3 of these mean the same thing. They're fully simplified, and they're correct. What you would not give me is something like this. Don't leave it like that with the double negatives. In mathematics, we simplify things. Simplify means if you see double negatives, make it a plus. If you see fractions that can be reduced, reduce them. All right, let's try another. Write the slope-intercept form of the equation of the line described. And I think I may need a little more space here, so I'm going to make this font a little smaller. All right, well, start with what you know. Slope-intercept form is y equals mx plus b. So I know I need that form for my answer. Now let's figure out what slope do I need. Well, my original slope is this, 2/3. I want my slope to be, I don't want it to be that big, 2/3. Here we go. I want my slope to be the opposite reciprocal of that. So one thing I know I need to do is I need to go from a positive to a negative, and I need to flip 2/3 around to give me 3/2. So this is the slope that I want to use when I'm doing my work, okay? And I want to use the slope right away before I substitute any numbers in. So the issue is here, I don't know what b is. And I can't use this +4 because I know that my equation has to pass through this point. It's going to have a very specific b value. So I'm going to actually put a little note here. And I'm going to highlight this part. And I'm going to highlight it a different color so that way it stands out. And I'll do the same color here. So basically, in that equation, when you do your work, you're going to ignore the b value of +4, okay? We need to solve for our b value for our answer. So if you recall from last time when we were doing this, what we do is we substitute the y1 for the y value, the x1 for the x value, and this m value for our slope. And then we solve for the b value. Once we have that, we write our equation. So that's what I'm going to do. Instead of y equals, I'm going to say 1 equals. Whoops, it's still highlighted. I'm going to say 1 equals. Instead of m times x, it's going to be -3/2 times, so notice how I'm using parentheses to demonstrate that I'm multiplying here. It's going to be times -2, and then plus b. So notice how I didn't use that +4 at all? Ignore this +4. You don't use this in your work. We're solving for a brand new b value by using this ordered pair and this slope. I wish that text box would go away. Okay, here we go. Here, let's just drag it like that. So again, you can use a calculator if this is going to be easy for you to do in a calculator, if you're really good with doing fractions. I tried to pick really nice problems where the fractions would cancel out when we're doing ones like this. If it's a little difficult to work with the fractions in a calculator, I suggest taking a piece of paper and working it out there. So if you multiply -3/2 with -2/1, if you want to make that a fraction, you can. The 2's are actually going to cancel out, and the negatives are actually going to cancel out. You should get a final product of 3. I still have a plus b though. I need to get the plus b by itself, which means I need to get rid of this 3. So this is an addition subtraction step. So I need to think about what the inverse would be to get rid of this 3. Well, the 3 is positive, so I want to subtract it. I'm going to subtract it to both sides, to the left and the right. So that way these cancel. And then if I combine these two, again, double check your mental math using a calculator, you should get -2, and b is now alone. So I've got my b value. I've got the m I want to use. Now all I have to do is put it together in an equation. Y equals -3/2 x minus 2. Here's my final answer. And again, if you want to get real fancy and show me where your final answer is for ones that require a lot of work, I suggest using a box like this. You'll just have to go back and make it transparent by clicking the little paint bucket. So that way I can actually see through it. All right, let's take a look at this one. It says, write the equation of the line described. And notice it doesn't give me a form for this one. I didn't bother because you're going to have either a horizontal or vertical line. There's really no special form that those are in. But we're still given criteria. It has to pass through this point. It has to be perpendicular to this equation. Well, y equals a number is either a horizontal or vertical line. If you are forgetting which of that is, I'm going to upload this as a PDF, go back to this table, and find the equation that looks like that. An equation that's going to be perpendicular to this is going to look like this. It's going to be a vertical line. So that's what I want here in my answer. I give you a horizontal, you give me a vertical, x equals. And it just has to pass through this point. So I want to take the x value from that point. Done. That's my final answer. And see through. Write the equation of the line described. Passes through this point, perpendicular to x equals 3. So it's the opposite. I gave you a vertical, you give me a horizontal. Y equals. And I just take the y value from that point. Done. That's my answer. So horizontal and vertical are very, very easy, so long as you don't start mixing them up with parallel. If you recall, for parallel, you give me the same type of equation. For perpendicular, you give me the opposite. All right, and now for the hardest type. This was the hardest type last time, and this is the hardest type again. I've only included one this time, however, for the sake of time. If I feel like we need a little more practice on doing problems like this, we'll do more practice on this after spring break. All right, so I'm actually gonna make the font a little smaller so I've got a little more space. Okay, so I want the standard form of the equation of the line described. It's got to pass through this point and be perpendicular to y equals 4x minus 2. Okay, start with what you know. I know that standard form is ax plus by equals c. And I've included the rules here. A, b, and c have to be integers, so no fractions, no decimals, and the a value has to be positive. But if you recall from last time, we can't directly write our equation in this form. We first have to start in some other form, like point slope, which I think is the easiest way to start, and then convert to that form. So here are the steps. First, write an equation in point slope. Here's point slope, y minus y1 equals m, parentheses x minus x1. I first need to write my equation in this form, and then convert it to standard form, okay? And before I do that, just like last time when we were doing the other slanted lines, I need to figure out what slope am I going to want to substitute here. Well, my original slope is this, positive 4, and I'm going to make it a fraction, 4 over 1. I want to do two things to that slope. I want to make it negative because it was originally positive, and I want to flip it upside down to make it a 1/4. Here's the slope that I'm going to need to use when I do my work. Okay, very important to do that part first. So let's go ahead and write a point slope equation. It's going to be y minus, and I substitute the y value in, negative 3, equals, I substitute my m value that I want. In this case, it's now going to be negative 1/4. Open my set of parentheses, x minus, and I substitute the x value from this point. Okay. Before I try to convert this, I'm going to simplify this a little bit. I'm going to simplify the double negatives. Oops. Actually, I'm going to do it underneath. I'm going to do it down here. Instead of minus minus, I'm going to write plus 3. My slope stays a negative 1/4. I can also simplify this double negative, x plus 4, instead of x minus minus 4. Okay, so we've got an equation. It's not in the correct form though. I want it in standard form. Whoops. I want it in this form. So a couple things that I need to get rid of. One thing I definitely need to get rid of first, the parentheses. To get rid of that, I'm just going to distribute. Negative 1/4 times x gives me negative 1/4 x. And then I'm going to distribute to the next term. And I tried to pick a nice slope so that way some of this would work out a little bit nicer. Negative 1/4 times 4. Again, you can use your calculator if you're good with using your calculator with fractions, or you could write this out on a piece of paper. But if you do this correctly, you should get a minus 1. The 4s will cancel out and you should get a minus 1. Negative times positive gives us the minus. These two cancel out and give us 1. Okay, so the parentheses are gone. Now I've got terms to move around. This is the hardest part about trying to write something in standard form, is just all the work that you have to do to get it there. I want the x and the y term together, and I want my constant by itself. Remember, to move terms from one side to the other, you add or subtract them. And it doesn't matter which term you move first. I think I'm going to go ahead and move the constant over to the right first, which means I want this 3 over here. To move it, I do the opposite sign of what I see. It's originally plus, so I subtract it. I do it to this side as well. These are going to go away, and I'm left with y equals negative 1/4 x. Signs are the same, so I add them and get 4. I match the sign of the things I added, so minus 4. As you can see, I've run out of space, but it's still not in standard form, so guess what I'm going to do? I'm going to add a text box to the side here, and I'm going to keep going. I'm actually just going to take this and copy paste it here so I can refer to my work a little bit easier. All right, next thing that I need to do is I need to get the x term over here. So in order to do that, I look at the sign. It's a minus, so I need to add it. I'm going to add 1/4 x to the left, and I'm going to add 1/4 x to the right so that they cancel. And I get the following. I can't combine these. Again, this has an x and this has a y. They're not like terms, but I can write them next to each other. I have a 1/4 x and I have a positive y. I know it's positive because there's nothing to the left, so I put a plus sign there. Equals minus 4. I still have a negative 4 on the right. This is almost standard form. I've got the x and the y together, and I've got my constant. The only thing is that I see a fraction. That's not an integer. I need everything to be an integer. So what I'm going to do here is multiply everything in this equation by the LCD. So my LCD, I'm just going to look at all of my fractions. Well, I only see one, so my LCD is going to be the denominator of that fraction. So if I do times 4 to all of these terms, so times 4, times 4, times 4, then that should give me my final answer. 1/4 times 4 gives me 1. 1 times 4 gives me 4. Negative 4 times 4 gives me negative 16. So this down here should be my final answer. 1x plus 4y equals negative 16. Everything is an integer. X and y are together, constants over here. The a value is positive. So I'm going to put a box around my final answer. If you can do problems like this with ease, you're in pretty good shape. Okay, so I'm going to end the lesson here so it doesn't get too long. Let's go ahead and say that the You Try slides on your interactive slideshow that goes with this lesson are going to be due Thursday. That's the day before Good Friday. So give them a go. As usual, if you are running into issues, leave comments on Google Classroom, message me, email me, and if need be, we can even do a one-on-one Google Meet so I can explain things in real time. All right, good luck. Take care.